Hello, good everyone. Welcome. This is Matt with Big Ben. So we want to solve this question, and this question is a second order linear non-homogeneous differential equation with constant coefficient. Exactly. So to solve this question now, we are going to obtain the homogeneous part and the particular part. So now let's write the equation as this: y is equals to yh plus yp. That is to say, to obtain the value of this very equation, we're going to obtain the homogeneous part and the particular part. Exactly. So now we want to get the y homogeneous. And how do we get the y homogeneous? Firstly, we need to first, get the characteristic equation. Exactly. Since this is a second order, derivative, so it has to be my m2. Exactly. So m raised to the power of what? 2, then minus. Now, we do not have first derivative because this is second order derivative. Now, since we don't have a first derivative, we just have a constant which is 9. I have 9 here is equals to what? 0. Now, I am solving for the homogeneous part. And for the homogeneous, the right-hand side should be equals to what? Equals to 0. So next, I have to solve this. Now, by observation, this guy here is the quadratic equation. So how do we go about it? So this will give me, if I want to factorize this now, very simple. I have to open, the bracket this way equals to 0. So I have it to be m here, 3 here, m here, 3. Here is minus and here is plus. Exactly. So by so doing here, I have here to be m is equals to 3 or m is equals to negative 3. Exactly. So by virtue of the constant coefficient, my particular part my homogeneous part, right? Y homogeneous will now be equals to, here I should be having c exponential, I can call it c1 exponential mx or m1x plus c2 exponential m2x. Exactly. So this is the pattern by which we represent the homogeneous part. Are we together? So this, our m1 will be this, our m2 will be this. Are we together? So my y homogeneous now will now be equals to c subscript 1 exponential m1 is 3. I have 3 because they have distinct roots. Exactly. So what I have here, I have x here plus c2 exponential m2 is negative 3, which is negative 3 as our m, then this. So this guy here is my homogeneous part. Are we together? So we've gotten the y homogeneous. So next now, guys, we need to obtain the particular solution of this very question. We want to obtain the y particular, the particular part of this very question. And for you to consider solving the particular part of this question, we need to watch what do we have on the right hand side. If you watch here, we have exponential, and it's an exponential function. So therefore, my y particular will have to appear this way: a exponential of x. Are we together now? So since the right hand side is an exponential function, then the particular part, or particular solution will be expressed in this format. Now, if you watch very well, we have second order derivative. So it means we're going to differentiate this guy 2 times. Exactly. Then we now substitute back to this very equation. So now if I look for y, y prime of p. Exactly. Now this y prime of p means I'm differentiating this one once. And if I differentiate this one, it still remains the same. Exactly, it remains the same. So next, to obtain the second order, I'll have to differentiate this one twice. Okay, subsequently, from where I stop here, I'll differentiate again. And this guy will still give me the same thing. Are we together, guys? Give me the same thing. So now we've gotten this particular function, which is this. Okay, we do not have this because it is missing in the very question. So next, I will now substitute. So next, we substitute back. We substitute back to our equation. Exactly. Good. So in place of this second order derivative, I'm going to put this, because this y prime here means second order derivative. So what I have here, I have it to be a exponential. What I have here, x. What I have here, minus. I have minus. Here is 9, so I have 9 here. Now, if you watch it, we don't have a first order derivative. It's just y. Exactly. So I now have a exponential. Now remember, this y here have to be our yp. Exactly. And our yp here is a exponential what? X. Okay? Which is equals to exponential of what? X. Are we making sense? So here they're saying 1a minus 9a, which is what? Which will give us minus 8a exponential what? X, which is now equals to, okay, this will be implied, which is now equals to exponential of x. Are we together? Now I want to obtain the value of a, because the aim is to obtain the value of what? This a. This guy is what we want to obtain there, the constant of constant coefficient. Exactly. So by doing that, now if I should divide everything by minus 8 exponential of x and minus 8 exponential of x, exactly. So this will go with this and this will go with this. So if you watch here, I'll be having something like a here is now equals to minus, what I have here, this cancel this, and I have minus 1 over 8. So the constant a is now what? 1 over 8, but in negative, minus 1 over 8. Exactly. This is 1 over 8. So next now is to get the complete solution. And the complete solution is this, that y is equals to y homogeneous plus y particular. Okay, so y is equals to y homogeneous plus y particular. Are we together? So when we have this guy, so to get my final answer, y will now be equals to, what is my y homogeneous? This is my y homogeneous. Are we together, guys? This is my y homogeneous, which is what? C1 exponential 3x, then plus C2 exponential minus 3x. Then I'm going to add here plus the y particular. That is the particular part of the solution, which we just got. Okay. Now, the particular part of the solution will now be this. Okay, let me just write it here. So there, the y particular, yp, should be equals to minus 1 over 8, which we've gotten, then e power what? E power x. So here now, guys, I now have it plus, but because this plus will react with this minus sign, so plus minus is minus, I now have minus 1 over 8, exactly, then exponential of what? Of x. Are we together, guys? So by so doing, this guy here becomes my answer. Okay, good. We use this method of undetermined coefficients. So this method I used to solve is called the method of undetermined coefficients. Yeah, because we discovered that the functions here are not so much. Okay, so subsequently, well, when the particular part becomes too ambiguous, that is when we cannot apply maybe the complex exponential method or something. So I hope this method or this question made you guys very well. If you love what we've just done here, please like, share, subscribe, and follow. Thank you very much. You have a wonderful time.